Take any Ashkenazi Jew, from New York, Tel Aviv, Kiev, Buenos Aires. In the United States alone, there are about 6 million of them, more than in Israel itself. Now look at his Y chromosome, a special part of DNA that every man gets only from his father and passes only to his sons. An endless male chain, never mixing with the female one. And this Y chromosome almost always points to one place on the map: Judea, the ancient Levant, that very Middle East where Jewish history was supposed to begin. Now take his mitochondrial DNA, a special part of the genome that a person gets only from his mother, his grandmother, his great-grandmother, from the same endless female chain. And look where it leads. It does not lead to Judea. About half of all Ashkenazi Jews in the world trace their maternal line to just 4 women. 4 women who lived about 2,000 years ago became the great-grandmothers of 10 million people. But geneticists still cannot agree on who these 4 women were and where they lived. Some say they were Jewish women who came from Jerusalem together with their husbands. Others say they were Roman women, Greek women, Italian women, converts to Judaism 2,000 years ago in the very heart of the Roman Empire. Who are the Ashkenazi Jews really? If their fathers came from Judea, where did their mothers come from? And why has science still not settled this dispute for 30 years, even though researchers have thousands of DNA samples, ancient skeletons, and the latest methods at their disposal? Today, we will follow 2 lines of the same DNA, the male and the female. They begin at the same point, split for thousands of years, and come together again in medieval Germany, in graves that scientists opened just 11 years ago. And what those graves revealed shifted the center of gravity of the entire debate about Ashkenazi origins. Let's start with the paternal line. In 2000, geneticist Michael Hammer and his team at the University of Arizona published a paper in PNAS that became the foundation of all later Jewish genetics. They analyzed Y chromosomes from 1,371 men from 7 Jewish communities around the world, from Ashkenazim to Yemeni and Ethiopian Jews, and compared them with non-Jewish populations from the same regions. The result was almost unbelievable for populations that had lived completely apart for 1,500 years. Jewish communities that had never met each other, separated by thousands of miles and different languages, turned out to be genetically closer to one another than to their non-Jewish neighbors. An Ashkenazi man from a Polish shtetl was closer by Y chromosome to a Yemeni Jew than to his Polish neighbor. And all together they formed one common group with Palestinians, Syrians, Lebanese, and Druze. The 3 main paternal lines among Ashkenazim were labeled in science as J1, J2, and E1b1b. These labels are called haplogroups, major branches on the human family tree that scientists distinguish by characteristic DNA markers. And all 3 Ashkenazi lines are Middle Eastern. Their roots go back to the ancient Levant and the Fertile Crescent, the lands of modern-day Israel, Syria, Jordan, Iran, and Anatolia, the ancient cradle of agriculture. The European contribution to the Ashkenazi paternal line exists, but it is limited. According to different estimates, from 5 to 23% over 80 generations of life in Europe. Genetic isolation was almost complete. So, on the paternal side, we have a solid scientific consensus. Ashkenazim are part of the Middle Eastern genetic world. Their male line ancestors came from the land where modern Israel is now located. The story could have ended there, if not for one thing. Every person has not only a father, but a mother. And when geneticists began to read mitochondrial DNA, the kind that is passed only through the maternal line, it turned out that the answer to the second question is much more complicated than the first. And with each new study, it kept changing. If the Y chromosome answers the question, who was my father's father? Mitochondrial DNA answers the mirror question, who was my mother's mother? In 2006, Doron Bahar and his team published a study in the American Journal of Human Genetics that showed something unusual for the first time. They analyzed complete mitochondrial genomes in Ashkenazim and found a striking pattern. About half of the entire Ashkenazi maternal gene pool traced back to just 4 women. 4 specific lines, known in science as K1A1B1A, K1A9, K2A2A1, and N1B2. These codes are just scientific numbers for different maternal lines, like flight numbers on a departures board. Behind each code stands one specific woman from whom millions of descendants came over 2,000 years. 3 of these 4 lines belong to haplogroup K, and 1 to the rarer N1b. For almost half of Ashkenazi Jews worldwide, mitochondrial DNA leads back to one of these 4 women. That is a massive narrowing. In most populations, the maternal gene pool is spread across hundreds or thousands of ancient lines. But among Ashkenazim, 4 women account for half the population. That only happens with a very strong founder effect. A tiny group remains isolated from an entire people, and it is from them that millions of descendants emerge centuries later. The genes of a few survivors are copied again and again, becoming typical of the whole group. Among Ashkenazim, the paternal lines also went through a bottleneck. But on the paternal side, the source is clear: the Levant, a consensus. The question of who these 4 mothers were and where they came from became the central mystery of Jewish genetics. Behar and his team compared these 4 lines with databases from the Middle East, Europe, and the Caucasus. And they concluded that these 4 women most likely came from the Levant. They came to Europe with the men, and here their descendants exploded demographically. The picture looked neat. Fathers and mothers from the Middle East. Both halves of the genome point to the same place. But there was one problem. The 4 Ashkenazi lines are extremely rare anywhere else. They are almost absent in both the Middle East and Europe. To understand where they really came from, a different methodology was needed. And 7 years later, it appeared. And it turned everything upside down. In October 2013, Nature Communications published a study by Marta Costa and Martin Richards from the University of Leeds. They assembled an unprecedented sample, about 1,000 mitochondrial DNA samples from haplogroup K in Europe and the Middle East, plus a database of 836 Ashkenazi control sequences. But most importantly, they used a new approach. Before, geneticists compared frequencies, where each line was found more often. Costa and Richards built a phylogenetic tree, a family tree of the DNA lines themselves, showing which lines came from which. It is like a family genealogy tree, but not for people, for genes. The logic is simple. If an Ashkenazi line is deeply nested within an ancient European cluster, then that line is European. If it is nested within a Middle Eastern one, then it came from the Middle East. And this is what the tree showed. All 4 founders turned out to be deeply nested within ancient European clusters. K1A1B1A, the most common Ashkenazi line, about 20% of the entire gene pool, was nested within a cluster 11,500 years old, with Italian, German, and British branches. K1A9 and K2A2A1 were in Western European and Mediterranean clusters 8 to 10,000 years old. And even N1B2, which in 2006 was considered a classic Middle Eastern line, was, in the new analysis, nested within a European cluster with Italian branches that split from the Ashkenazi line about 5,000 years ago. According to the Costa team's conclusions, all 4 founders were European. That meant the fathers came from Jerusalem, and the mothers came from Rome. And when Costa and her team also checked rarer maternal lines, the picture only deepened. About 90% of the tested Ashkenazi branches in each of the additional lines were also European. Some of them formed in Europe tens of thousands of years ago, long before the Jewish people existed. The overall estimate? From 65 to 81% of all Ashkenazi maternal lines have prehistoric European origins. Middle Eastern lines make up only about 8 to 10%. And here came the heaviest question in Jewish genetics. If the fathers came from the Middle East and the mothers were European women, where and when did these European women enter Jewish communities? The answer had to be sought in the only place where such a meeting was even possible on that scale. Most people think the Jewish diaspora began in 70 CE, when the Romans destroyed the Temple in Jerusalem. That is wrong. Jewish communities existed all across the Mediterranean long before that. Already in the 1st century BCE, tens of thousands of Jews lived in Rome itself, and even more in Alexandria. Large communities flourished in the cities of the Eastern Mediterranean and throughout southern Italy. In the 1st century CE, Judaism was one of the fastest-growing religions in the Roman Empire. The Jewish historian Josephus, writing in the second half of the 1st century, described the situation in Syrian Damascus, where, according to him, almost all the wives of the locals had converted to Judaism. Roman authors noted with irritation how more and more imperial citizens were beginning to observe the Sabbath and avoid pork. Judaism spread across all social classes, but, according to Josephus, women converted especially often. According to different historical estimates, by the 1st century CE, there were 4 to 7 million Jews living in the Roman Empire, perhaps up to 1/10 of the empire's total population. A significant part of this growth was due not only to high birth rates, but also to mass conversions. First and foremost, female ones. And this is where the mathematics of the two lines comes together. Imagine the 1st century CE. Young Judean men arrive from Judea in Roman cities. Traders, soldiers, freed slaves. They marry local women. But according to Jewish law, Jewish identity is passed through the maternal line. This rule had already been established by then. So the local wife had to convert to Judaism for her children to be considered Jewish. She converted. And her mitochondrial DNA, European, Roman, Italian, entered the Jewish gene pool forever, together with the Y chromosome of her husband, who came from Judea. That is how the sex imbalance visible in DNA today came about. Converted to Judaism, these women became part of a people whose descendants, 1,000 years later, would be called Ashkenazim. From Rome and southern Italy, these mixed communities gradually moved north. By the 9th century, they settled in the Rhine Valley under the protection of Charlemagne and his successors. From there, already speaking Yiddish, the Ashkenazim would move on to Poland, Lithuania, and Ukraine. A few pogroms, sharp population bottlenecks, a second wave of the founder effect, and by the 19th century, half of the world's Jews will be genetic descendants of the same 4 women whose lines began in the age of the Caesars. It is a neat, elegant, almost cinematic story. But in the 21st century, it began to be re-examined. And the first blow to it came not from a laboratory, but from beneath the ground. Quite literally. In 2013, the same year Costa's paper came out, builders in the German city of Erfurt began converting an old 15th century barn into a parking garage. The excavator dug into the ground and hit human remains. Beneath the barn turned out to be a medieval Jewish cemetery from the 14th century. The Rabbinical Council gave permission to study only individual teeth. A team led by Shai Carmi from the Hebrew University of Jerusalem and David Reich from Harvard obtained DNA from 33 medieval Ashkenazim. The results were published in Cell in 2022. These medieval Jews turned out to be genetically almost identical to modern Ashkenazim. But their ancestral makeup was unexpected. Under the most likely model, 65% Southern Italian ancestry, 19% Levantine, and 16% Eastern European. Southern Italy was once again coming to the foreground. But there is a critical nuance here. The Italian DNA of that period was already mixed. During the Roman Empire, a huge wave of migrants from the Middle East came to Italy, and ancient Roman DNA analyses showed a significant Levantine component. So the Italian part of Ashkenazim is already a mixed Levantine-Italian blend. And in 2025, Yosef Livni and Karl Skorecki published a paper in Human Gene that reignited the debate. They took a different path. Their logic is this. When a small group of founders lives inside a large surrounding population, it inevitably absorbs outside maternal lines through marriages and conversions. Absorbed lines enter the gene pool as single copies. But the true founder lines over centuries are copied many times through generations of daughters and appear in dozens and hundreds of copies. Livni and Skorecki calculated this ratio among Ashkenazim. The result? Less than 15% of Ashkenazi mitochondrial DNA is absorbed. The rest are founder lines. From this, they concluded, if absorption contributed only 15%, then the hypothesis that the Ashkenazi maternal pool is mostly European women assimilated into the communities does not hold mathematically. The founder lines must have come already from the Middle East, together with the men. Costa's team argues that absorption at the beginning of a population's history and absorption 1,000 years later are different phenomena, and Livni's methodology only sees the latter. But the dispute, now 30 years old, is not over. Two halves of the same genome tell two different stories. The Y chromosome confidently leads to Judea, mitochondrial DNA, sometimes to coastal Rome, sometimes back to the Levant, depending on which geneticist you ask. But both stories are true at the same time. Because the very boundary between European and Middle Eastern in the case of Ashkenazim is false. First-century Rome was already a mixture. The Italian DNA of that era already contained a Levantine trace. And the four women from whom half of the world's Ashkenazim descend may have been Jewish women who came from Judea, or Italian women who converted to Judaism, or, most likely, both at once. If you are an Ashkenazi Jew, both halves of this story are written in your genome. The Y chromosome that came from the land between the Jordan and the sea. The mitochondrial DNA, whose trail scientists trace sometimes between the Tiber and Vesuvius, sometimes back to the shores of Galilee. Two paths that converged once 2,000 years ago and never managed to separate again. Your fathers came from Judea. Your mothers are still a matter of debate. And that debate, not its resolution, is the true story of the Ashkenazim.